Hello 10A students. Today I'm going to be walking you through this question. It comes from section 4.3 and it goes as follows. So in the following exercises, find the local and or absolute maxima for the functions over the specified domain. Here our function is the square root of x minus the square root of x cubed over the domain 0 to 4. So we want to find the local and or absolute maxima. To do this, there are only a few specific locations that such a local and or absolute maxima can occur. When we're working over a closed interval, these locations are at the endpoints of the interval as well as the critical points of the function. So the critical points are where the function's first derivative is either 0 or undefined, and then we also have the boundary points. So first, let's just consider the boundary points. So at x equals 0, our function is the square root of 0 minus the square root of 0 cubed. This is 0. Okay. At x equals 4, our function becomes the square root of 4 minus the square root of 4 cubed. This is equal to 2 minus the square root of 64, which is 2 minus 8, which is negative 6. So far, our candidates for a local and or absolute maxima is at x equals 0, because that's greater than negative 6. But as I said before, these aren't the only two options. We also need to consider when the first derivative is 0 or undefined. So let's take the first derivative of this function. This function, I can rewrite it as x to the 1/2 minus x to the 3/2. This will make taking the derivative easier. And taking the derivative and using the power rule, this becomes 1/2 x to the minus 1/2 minus 3/2 x to the 1/2. Now we want to determine the x values when this is equal to 0. So, or undefined. And if I rewrite this using negative 1/2 and 1/2 as their square roots, what this looks like is 1 over 2 square root of x minus 3 over 2, or 3 square root of x over 2, equal to 0. So pretty clearly here, because we have a square root x in the denominator, x can be undefined at, or the first derivative is undefined at x equals 0. So this is a critical point, and we've already evaluated it. We know that the value of the function at x equals 0 is 0. Now, to determine other possible critical points, because we've already considered the case where x equals 0, I can multiply both sides of this equation by square root of x and get 1/2 minus 3/2 x equals 0. And adding 3/2 x to both sides, this becomes 1/2 is equal to 3/2 x. Multiplying both sides by 2, I get 1 is equal to 3x, implies x is equal to 1/3. So when x is equal to 1/3, this equation the first derivative of the function becomes 0. So our final candidate is at x equals 1/3. And plugging this back into the equation, that's the square root of 1/3 minus the square root of 1/3 cubed. And doing a bit of simplification, what this looks like is 1 over square root of 3 minus 1 over, and this is the square root of 9 times 3, so we can pull the first 9 out and make it a 3 square root 3. Simplifying even further, this becomes 3 minus 1 over 3 square root 3 just by combining the two fractions. So ultimately you get 2 over 3 square root 3, And then by rationalizing the denominator, the final result is 2 square root of 3 over 9. Okay, so our 3 possible candidates for the local and or absolute maximum are 0, 0, 4, negative 6, and 1/3 2 square root 3 over 9. Now, only one of these is positive, this 2 square root 3 over 9, so this is certainly going to be our absolute maxima. And then to know if this is a local maxima or not, the textbook recommends graphing the function. There are other techniques that you will learn later, but for right now, we can just consider the graph of the function to determine if this is local or just the absolute maximum. Using a graphing calculator, you will observe that the function takes this form. So at 1/3, we do see that this is a local maximum. Hence, this is both the absolute and the local maximum, 2 square root 3 over 9. Thank you.